Dude, let's solve some one-step inequalities. Sound good? Okay, now you've solved one-step equations, you solved multi-step equations. Now we're getting into the inequality game, which instead of x equals 7, you're going to get stuff like x. We're just going to start writing all over the board, I guess. Okay. I don't know what's going on here. Weird. So you'll get like x is less than 7, which means x could be 6, could be 6.3, could be negative 550. So it gives you all of the solutions that could work. So when we put our solutions to inequalities down, we're going to put them on a number line, which I'll show you on the next slide here. But here's the one important thing when you're solving inequalities. If you multiply or divide both sides by a negative number, you have to flip the inequality sign. So that's the tough part to remember. Only when you multiply or divide both sides by a negative. So check this stuff out. Let me extend page here. I have a little song that helps me remember which way I'm going to shade when I'm graphing these. And it goes a little something like this. If the letter is first, then follow the arrow. If the letter is second, then don't. And if the letter is third, then, I don't know, go pick up a turd and do your math homework. Really, you only have to worry about if the letter's first, you follow the arrow. So if you end up with something like x is greater than 5, and you're on a number line here, and you've got like 5, and there's 4 and 3 and 2 and 1. This side would be 6 and 7. The letter's first, so you're going to follow the arrow. So you would shade to the right of 5. But you also need a dot on 5. So if it is less than, or if it is greater than, it's going to be an open dot on that number. And then the shading, if the letter's first, follow the arrow. The letter is first, so we would shade to the right. So it would show just like this. And this is what we're going to practice all day. So if the letter's first, follow the arrow. Now the dot thing, the reason this is open is it's saying 5 is not part of that solution. Because you can't say that 5 is greater than 5. That's not true. But if it was x is greater than or equal to 5, then it would be filled in because 5 is included. Because you can say that 5 is greater than or equal to 5. That is true. So my thing is, if they use the extra ink to do the or equal to's, then you got to use the extra ink to fill in your dot, okay? So let's go ahead and try one of these out. Negative 12 is greater than x minus 7. You solve them just like with the equal sign. I'm trying to get x by itself, which means I have to get rid of minus 7. So we use inverse operations, like always. The opposite of minus 7 is plus 7. Now if you do it on one side, you have to keep it balanced and do it to the other side of the inequality as well. Negative 12, you owe grandma $12. Positive 7, you have $7. So you're still short $5. So we have negative 5 is greater than x. So this can also be written in reverse. If negative 5 is greater than x, you can also write that as x is less than negative 5. They're the same thing. So it doesn't matter. So you're going to put it on a number line. You can make your number line as detailed as you want. I'm only looking for one number. I'm only looking for that negative 5. So really, you could just put negative 5 there. It's just greater than or less than if you're looking at this side. So that would be an open dot. And let's look at this one, because that's what we originally had. The letter's not first, and it points to the right. And the song, the great song, says if the letter's first, follow the arrow. If the letter's second, then don't. Ooh. So the letter's second, we're not going to follow the arrow. It points right, so we're going to shade to the left. We've got one example under the belt. Get ready for some more.